we now want to take a look at what we call the multiplication law of probability. Now, if I take a look at what this particular law of probability says, it says if A and B are any two events, then to find the probability of A, remember that little hump there is just a shorthand for the word and. If I want to find the probability of A and B, I have some ways to calculate it that use conditional probabilities. Now this might seem strange because again, you might recall that in the last video we said that finding an and was going to be unbelievably easy to do because I could just go to my table and look for an overlap. No need to use a fancy formula. This formula would be way harder or make something like part C in the last question way harder to answer. But what we're going to see here is that this and that we're going to have, we're really going to be treating as kind of like an and then, as in kind of like a progression through time. To kind of get a sense of where this formula comes from, we should be able to note that up above in these previous problems, we were using a conditional probability formula that had like probability of A given B was equal to the probability of A and B over the probability of the piece that was given. Notice though that with just a tiny bit of algebra, I could go ahead and I could multiply both sides by probability of B. And if I was to do that, I would notice that over on the right side, these pieces would cancel out. And notice I would be left with exactly this statement. Probability of B times probability of A given B. And then on the other side, probability of A and B. So that's exactly what I have. Notice that if I change the order of the conditional probability, I actually can change a little bit of what I'm going to get over here. So I have kind of two different ways I can think about this being set up, although essentially they're equivalent. Well, let's take a look at how we can actually use this to help answer some different questions. And we'll see that a lot of these questions aren't too difficult, but they do require that we think carefully about the scenario. Let's see what we have here. Example number 3. Assume in a group of 10 people that 3 of them smoke. You want to collect a sample of 2 individuals from this group of 10. If 2 people are selected at random, then find these different probabilities. Okay. The hardest part a lot of times with working through these probability questions is that people try to read through them too quickly without trying to understand and visualize the scenario. So sometimes to go ahead and help, it might be useful to just go ahead and do something even as silly as the following. Just to say, okay, let's imagine I have a room full of people here. I have 3 people that smoke, and I have then 7 people that do not smoke. Let's call that S complement. And now I can start to think about the question that I have. I'm going to be going into this room and I'm going to be randomly selecting 2 individuals. Imagine I'm going to select somebody first, and then I'm going to select somebody second. Maybe I'm going to like take them into a separate room and do an interview or something like that. Well, then I can find the probability that both of the selected people are smokers. Let's see how we would set that up. Well, that would be something like probability of S. Oops, let me rewrite that. Probability of S and S again. Kind of like here, I'm saying that this person here is my first smoker that I select, and the next person is the second smoker that I select. Right? So I'm kind of indicating an order. First I do this, and then I do that. Now, again, since this question has no table where I can easily go grab this overlap of the categories S and S, like we were able to do up here on the previous problem, I'm kind of stuck. I can't just automatically calculate this. I need this multiplication law. So here's what my multiplication law says. If I was to fill it in, it would say that I'm going to have to do the probability of S. I'm going to make this S with a subscript of a 1 on it, just so I know it stands for this first smoker. Well, my second smoker with an S number 2. So I'm going to have to first figure out what's the probability of selecting my first smoker. And then, notice the order up here. The first value that I had in the probability notation now becomes the given. It works in both iterations of the formula. So I'm now going to say I want the probability that I select smoker 2 given that I've already selected smoker number 1. Well, let's think about this. It actually should make a lot of sense that this is how this would be set up. So let's go through and think about it first. Let's suppose I'm just going to try to find this first probability. I want to walk into the room, randomly pick someone, and I'm curious if they're going to be a smoker. Well, what are the chances that if I'm randomly picking someone out of this room, I'm going to end up with someone who smokes? Well, again, I could see that I have a choice of 10 people to choose from, and 3 of them are smokers. So I have a 3 in 10 chance of picking someone who smokes. Now, let's assume that I actually took one of those smokers and I brought them outside the room, right? So maybe it's like this smoker is now removed from the room. Well, now when I go back to the room and I pick again, I'm going to say I have to keep in mind the first smoker, S number 1, was already taken out of the room. And so with that in mind, let's compute the chances of pulling a second smoker. Well, now notice that when I go to the room, how many people are left to pick from? Well, yeah, there's 9. There's 1 less because 1 person stepped out. How many smokers are there left for me to grab? Well, there are 2. And so if I crunch this out, I'm going to end up with something like 6 over 90. Or if I rounded this off, I would get 0.0667. So hopefully you can kind of see how this process of selecting something first and then something second appears to work. Well, let's take a look at part B and see if we can do this again. I want to find the probability that, here's an important term, at least one of the 2 people happens to be a smoker. Okay, the moment that I start to see phrases like at least 1 or at least 2, I often think that this means that it's a good time to make a sample space. That is, I can think here about the number of smokers that I could end up with, right? Like how many smokers might I end up with when I make my selection? Well, let's see. I could end up with I could end up with 2 smokers, right? Like I select a smoker and then I select another smoker. That's totally a possibility. I also think, though, I could just end up with 1 smoker. Well, there's a couple different ways for that to happen. I could select a smoker and then a non-smoker, or I could pick them in the opposite order. So there are 2 different ways for me to get only 1 smoker. But I could also end up with no smokers at all when I go ahead and make this selection. So my sample space here is really kind of like I could either get 2, 1, or 0. That kind of corresponds to these 4 different possible outcomes of what could actually happen. So I want to see here, which of these scenarios am I interested in if I want at least 1 smoker? Well, seems like here I'm interested in getting 2 smokers. That would be okay, because remember, 1 is the least that I'm willing to tolerate. I'm okay with either of these cases, but the only case I'm not okay with is this one. So I can go ahead and think about the following. I could state that I'm okay with getting a smoker and a smoker, or I would be perfectly okay with getting a smoker and non-smoker, or I'm totally okay with a non-smoker and a smoker. Any of those are fine. And notice that would mean that based on our rules for OR, I would have to find all 3 of the probabilities that are checked off here, these check marks. I have to find probabilities for each one of these occurrences, kind of take their sum total. Now that can be a lot of work. It's doable, but it's a lot of work. So I'm going to go ahead and write down this. I'm going to say I could do the probability of at least 1 smoker. I could do that by finding the probability of, let me rewrite that again, by doing the probability of S and then S, so smoker and smoker. I could then add to that the probability of S and S complement. And then I could add to that the probability of S complement and S, right? These are all the different check-marked occurrences that I'm okay with. But this requires that I'm going to have to do 3 calculations. So I'm going to go ahead and try to think about this in a slightly different way. This is where the idea of complements from the last section becomes really, really important. I know that when I have a full sample space, the total probability when I add the probability of S and S, the probability of these S and S complement combos, and the probability of the S complement S complement, if I were to add all those probabilities together, I should get 100%. So what I'm going to do here is I'm going to take that 100% and I'm going to chop off the only probability that I do not want, which is a non-smoker and then a non-smoker again. Well, this probability should be a lot easier to calculate because it's only one probability. I would have to find the probability of first selecting a non-smoker, so I can call that smoker number 1 complement. And then I would say I want to go ahead and find the probability of picking a second smoker or non-smoker, given that I already selected the first. Again, just using my multiplication law. Well, let's see how we would actually think through this. I'm going to replace each one of these with an individual fraction. Okay, let's think about what each of those fractions would look like. For the first one, let's imagine again that I have a nice full room of individuals. So I want to go to this room and I want to say, how many people do I have to pick from? Well, there are 10 people. And what are the chances that I don't pull someone that smokes, pull a non-smoker? Well, there are 7 of those people in there. So I would have 7 out of 10 people. So again, that means that I've taken one of these non-smokers and I've pulled them out of the room. That was my first selection. Maybe it was this person. Now I have to go back to the room, keeping in mind that one person already left. I now know there are 9 people, and how many of them are non-smokers? Well, let's see, that's going to be 6 of them, so 6 out of 9. Now, if I go ahead and I compute this, this is going to look like, let's see, 1 minus 42 over 90. If I do that subtraction, I would end up with a fraction of like 48 over 90, or you could just jump right to the actual decimal itself, which is 0.5333. Now, I would have gotten the exact same total probability had I gone about doing this by adding these 3 separate probabilities up. And if you're interested, you can try to compute that yourself or take a look at my notes that are up online where I show both calculations. But this is an important thing to note here, is that sometimes when I come across these ideas of at least 1, or at least 2, or at most, when I get that sort of language, drawing out a sample space can be very helpful to try to think through what it is that we actually want in a scenario, what we don't want, and then we can try to come up with multiple ways to get to our answer.